those are certainly things that I want to predict. Say that again, please. Oh, you're recording. Other examples, predictive modeling in healthcare. What else would you do to try and predict things? What things would you want to predict? Trend rates. Absolutely. We have these large scale changes in demographics over time. We have changes going on in terms of what are the healthcare treatments. So I want to see what's going on in trends. Right now, we're in the middle of the pandemic, and we can understand that there are lots of transitions happening as vaccination rates go up and trends associated with ER usage, ICU usage, inpatient usage associated with COVID and non-COVID is changing. And then the ramifications, efficacy. So there's a lot of telemedicine happening. Is it effective? Can I predict who will receive the best care via telemedicine? So many examples in healthcare. Of course, it's a business, so predicting who might be the most expensive patients over time or the least expensive patients is very important for a health insurance company. And predicting who is the best candidate for a particular drug is very important. Bringing in genetics information, bringing in biomarkers, all different types of information to find the right treatment for the right patient at the right time. That's all predictive modeling. A lot of that work is work that I get involved in regularly, so it gets me very excited. But let's go to the next one. Finance and insurance. Predictive modeling in finance and insurance. Credit card companies, they're doing predictions, right? They have to predict what's the probability that someone is going to charge off. If they charge off and don't pay us, how much do I owe them? That's a big, big deal. Are they going to declare bankruptcy? If so, how much will the company lose? Investment banks have to make predictions all the time related to what's the future profitability of a company. How much should they be investing in that company? Private equity firms constantly do this, as well as venture capital, but I know we have life insurance people on here. So life insurance people, don't raise your hands because I can't see your hands, but give me some suggestions. What are some of the types of predictive models that happen and are necessary in life insurance industry? Go for it. I'm watching the chat box. Type away. I don't see anyone. Mortality, absolutely. Now, interestingly, there are these life tables, and life tables are very, very important, but there are improvements you can make by using machine learning models on predicting mortality. And I've done a lot of this work. You can get a better prediction of mortality using that than using the good old-fashioned tools of life tables and logistic regression and splitting them up in Kaplan-Meier curves. You can outperform that. Fraudulent claims, couldn't agree more. In fact, my first big job out of graduate school was identifying fraud cases. Fraud cases in credit cards, fraud cases associated with applications of fraud. Predicting mortality using prescription and medical data, absolutely. Take that information. There are some standard mortality indicators, and there's a metric. It's called the Dale-Charlson comorbidity score. But if you layer on medication information, you'll get a more accurate prediction. If you layer on demographics, you get more information. But to put all that information together, best approach, supervised machine learning. It's a fantastic approach. Well, you've got great ideas there, and I don't want to interrupt you on that, but let's see what else we can talk about. Now, the first thing I want to mention is data science playbooks. So you talk about where I can use data science in general and predictive modeling. And the interesting thing is throughout a company, there's many, many, many different places it can be. Now, I described, and you gave me some great examples of use cases. Cases, for example, like lapse rate. Is someone going to simply stop paying? Do I have to worry about an attrition, right? So predicting churn and turnover. Well, that's a great example of operations metrics. But there's so many other applications. Thinking about assessing your models and how to optimize them. Segmenting your customers. There are some restrictions, but you can do often improvements in your models by segmenting them. Maybe I should build standalone models for men versus women. By the way, and in at least one state in the United States, you're not allowed to do that for life insurance. Does anyone know what state? Don't worry about it.
Ohio?
Profitability analysis. You can try to figure out, using the modeling, what is the most profitable product currently as well as over time by projecting using expected changes in demographics. Site selection. Oh, if you want to know the answer, don't worry, it's in my book. Read the book and you'll find out the answer. Go right to the life insurance chapter, trust me. Site selection. You've got multiple locations and you need to provide healthcare, or you have multiple agents selling life insurance. Should they be physically located in certain places? Are they physically traveling? Is it all virtual today? You can try to figure out what are the best locations for your business. How? Predictive modeling associated with what factors influence profitability. Forecasting. Good old-fashioned time series forecasting, very effective. I ran forecasting teams for a number of years, but we enhanced it using examples of machine learning as well. So it wasn't just good old-fashioned forecasting. Continuing to dig into that, as well as human resources modeling. No matter what company you are, there's always a human resources department. What do? They hire people, they promote people, they let people go. You can use analytics to try and figure out who is most likely to be a successful employee in the company, who's likely to attrite. You can do those types of things using predictive modeling. Okay, great. Well, is my company a good candidate for this? Or is a company I'm looking for a good candidate for it? It all depends. I've worked a lot with private equity firms, so I'm going to give you the lens that a private equity firm thinks about. When they want to ask themselves, is this company ready for predictive modeling? Key question they have is, do they have a lot of data already? Or are they just not aware of data? Known facts, are they behind the industry? Do they know what's out there? And do they know their competitors might be a lot stronger? If so, that is definitely a sign that they have an opportunity. The human resources capacity, do they have people who can do this? Because if they don't have any people who can do this, maybe they hire consultants, but you have to be able to absorb what the consultants do. Nobody wants to get a black box that they can't understand and can't understand if it's going wrong. What about the IT team? Is the IT team able to incorporate predictive modeling into the regular work? If so, great. If not, that's a problem. And what about the culture? Is the management supportive or not? Because if the management is not on board at the CEO level, you're never going to find a strong encouragement for predictive modeling. Luckily, life insurance has relied on predictive modeling for its entire existence. If it doesn't do predictive modeling, it's simply not going to exist. On the other hand, risk splitting and who can split risk best is a critical differentiating factor for many life insurance companies. Some of them try to differentiate themselves based on sales, but others try to have the best model. Some on customer service. Well, that's about the company, but what about the where? Where in the company should I be working if I talk about predictive modeling? Well, you'd like to work at the senior management level. At a minimum, the senior management have to understand and appreciate what you're doing. Because if they're not on board, your project is going to not have enough budget, it's going to get siloed, it's not going to go. So they need to be on board.
Can I ask a question here about,
go for it.
So one thing on this exam is you're tasked to explain things to a non-data science audience. Like you might fit a machine learning model and then explain it to your sales and marketing team. What types of graphs or statistics can you use to simply convey the usefulness of the model?
Great question. So there's a lot of technical models, statistics you can use. You can talk about lift curves, you can talk about those things, but at its core, my experience is I don't focus on graphs. If I'm talking to a non-technical audience, and when I say non-technical, it's someone who isn't usually using graphs in their regular conversation, I give them a few bullet points, take-home messages. What is the difference? So let's say I'm talking about there's a new machine learning model that has been implemented that is more accurate at predicting the probability that a patient will be readmitted to the hospital. Okay, it's a new model. It replaced the old one. I just try to explain, we have a new model. It's slightly more advanced in its structure and the data elements we use, and it's more accurate than the old one. It is, and I'll give them a number, X% more accurate. And if they're really interested, they'll try to figure out what does that X% mean, but they may not need it. So I really try to minimize the amount of details I provide, and I focus on the big picture. So, new predictive model, what makes it different? Usually, some data sources are different, and some of the advanced modeling assumptions are different. Beyond that, they just need to know it's new, it's better, it's this much better. And then when they want to know what this refers to, that's an interested party. That's the one I might dig into further and start working on the graphs. But I don't want to turn people off from a conversation that way. Back to who in the organization, you had marketing right there, and they can be fantastic partners. Why? Because the biggest challenge with marketing is ever showing, did it do any good? I spent millions of dollars on marketing. What was the return on investment? So if you're able to show what was the originally predicted response or the projected sales and an accurate projection of sales, what is your degree of accuracy? And then what was the response of the market? The marketing campaign, that's great. It's nice when it's a A/B campaign, right? And things are randomized, then it's easy to do, but it's not always that way. And so trying to understand how you can show value is critical. Of course, business intelligence teams, they're always providing updates, information, but how to make it a little bit more advanced, more technical, more value add, they're happy to learn. And human resources is always interested in understanding how can they show the value of their work? How can they do a more effective job at recruiting? How can they do a better assessment of the candidate? How can they determine if the salary is appropriate? So predictive modeling can certainly help if they have a large database associated with what is their recruiting experience. And they can use that to assess what are the factors at the point of making a hiring decision, which are most critical in terms of predicting who will have career success. The challenge is defining what is career success, but that's something you work out within the human resources department. There's a broader question of data strategy, and that's a lot of fun. That's the one to do with the senior management, where you start and you have the conversation. What are our opportunities throughout the organization? What can we do better? Where are we behind? And that's a nice benchmarking exercise. If you have people internally, that's great. It's a perfect blue sky session where everyone you see in this who list is involved in the dialogue. And then from there, you have to figure out, do I need to make changes in my infrastructure? What modeling should I do? What's the top priority? And where can I get the value? Prioritizing your predictive modeling is absolutely critical. So we need to make sure that when you put that effort in, you're going after your best opportunity, and then you can implement it afterwards. Nobody wants an incredible model that can't be implemented. I'm going to give you a couple examples, only a couple, but then I'm going to pause and I'm going to hand it right back to Sam. So in terms of predictive modeling, there's so many different areas where it can be applied. One of the main ones that I like to focus on is loyalty programs. Loyalty programs are when someone is coming back for a reward over time. And what you can do is you can segment those populations into different groups. You can find what makes them excited and not excited. You can identify who are the most profitable customers, as well as try to figure out what is their desired, in this case, for a restaurant, what are their favorite things that they might want to try? New foods, more expensive foods, higher margin foods. If you're talking about healthcare, take everything I said about a restaurant and change it around. It's a patient. How do I segment my patients into different groups? What's the most appropriate way to do it? Who are the most profitable patients? How do I minimize my downside for the most expensive patients? How do I manage that? Each example from one industry has the same insights for another industry. Site selection model. You've got 200, 300 locations for a retail chain. You want to figure out which are the next sites that I should plant if I'm going to open up a new location. Okay, great. But what if instead of talking about a retail chain, I'm talking about something different? I'm talking about where do I provide my healthcare service? Which ones are the best locations from a patient point of view, from a profitability point of view? What about if I have physical locations for life insurance sales offices? Which are my most profitable ones? Which are my least profitable ones? Where's their cannibalization? When I open up a new office, what is my predicted profitability? Site selection modeling is critical. Modeling risk. Well, that is the bread and butter of life insurance companies and health insurance companies. But modeling that risk, you have many different ways you can approach it. As you start doing it, think about what's the breadth of variables you can include. The truth is, having a rich data set is the biggest game in town. If you have a lot of variables that are strongly predictive, you can build a good model, even with a simple assumption. Add more variables, you'll get a higher lift before you even invest in making the models far more complicated. My biggest early win was not from taking a simple regression model and making it advanced. It was finding a data source no one had thought of before, linking the telephone systems to the transaction systems. And the use of the telephone by our customers was an indicator of risk. The person who just started opening up an account and was calling us all the time, they were risky. But we didn't understand that until I was able to connect those data sets. Huge lift. My algorithm only got slightly more complicated, but it was about getting those extra variables into the model. Of course, there's lots of other fancy things you can do later. Got a client right now who is scaling up real estate at a national level. It's a fantastic client, and they need to predict how much rent can they charge for apartments. Well, if the prediction model isn't accurate, they don't know if they should buy the apartment or not. It might be a bad investment, it might be a good investment. So they need an accurate model. What data variables can I use? Well, what can I scrape off the web? What's already available? What do I know from the literature is already important? What model structure should I use? Should it be a regression model? Should it be a random forest, a GBML? Should I cluster? Should I segment my populations? The answer is, it's data science. Let's check it out. Let's figure it out. And so that's a really, really fun project. I'm going to pause. I did put my contact information up there. You're more than welcome to send me emails if you have questions. And of course, Sam can provide it as well offline. But I'm going to stop at this point. I'm going to stop sharing. And Sam, did you have any thoughts or questions you wanted to share with me about predictive modeling in the real world?
Yeah, I just wanted to tell everyone who's about to take this exam next week that this is going to be really useful for your writing, because you do need to just put words on the page. You need to write like 1,500 to 2,000 words. That used to be in the executive summary. It's now sort of spread out through the report. So all these business applications, like he talks about, limitations of data, different applications of predictive modeling, and being able to talk to different departments like sales, marketing, IT. You can use that just to add paragraph and paragraph. You can really just write a novel in your exam, and that will really show that you have domain expertise, that you really understand the material well, and it will help you to stand out. So you'll get more points on those questions. Even if you're a little bit wrong, even if your models aren't perfect, you can just, do what Howard just did and show that you have a degree of confidence and credibility in what you're doing.
Structure your thoughts. Let me tell you how, because I have to read 1 million essays. I teach at Columbia. What I love it is when I'm grading and I see that the person has already structured their thoughts and they go ahead and they tell me at the beginning where they're going to take me. So we have this project. The following things we want to be concerned about: the data sources and the breadth of the data sources, the data cleaning. How clean is the data? What will I have to do to wrangle that data? The modeling, the outcomes, the implementation. And I'm going to talk about each of the 5 in my following paragraphs. I may not even read the whole thing at that point because I know that they're in good shape. How you start your response frames everything. So start strong with giving an understanding of where you're going to take us in the story.
Yeah, and also showing the value of your model rather than showing all the details. Like, let's say you fit a generalized linear model, and you could show like the quantile plots and the deviance residuals graphs and the R squared and the adjusted R squared. But if you show that to like a sales rep, they're not going to know what that means. But if you just show them, an accuracy metric, then you can, explain to them how that's going to, improve their business. One when it comes to like, classification problems, one thing I think you talked about was like optimizing for the business outcome as opposed to just the statistical outcome. If you just look at like the AUC, you can just choose the model that has the highest AUC. But what if there's like an imbalanced data set where there's like, let's say you're doing fraud, fraudulent accounts, and only like 1% of fraudulent accounts, only 1% of accounts are fraudulent, but you need to be really thorough in not missing any accounts that are fraudulent, because that could cost your bank, $10 million. How would you like show a, like, let's say you're talking to like a bank manager, that your model's going to be reliable? What types of, statistics or outcomes or graphs could you use to show that?
You remind me of a great story, Sam. So one of the other big wins I had early on, to your point, was related to fraud. And when I came into the bank, they prioritized all of their fraud cases based on the probability of fraud. Whatever case had the highest probability was the one they did first. To which I said, I'm sorry, I thought we were a business. I thought we care about dollars. Maybe we prioritize it by what is our expected loss or maximum expected loss. Put this in terms of dollars. And we flipped it all the way around. And we changed that algorithm. Just the prioritization. What do I work on first? And as it turned out, that alone saved tens of millions of dollars. Tens of millions of dollars. So at its core, a business is a business. Focus on the dollars.
Yeah, and a great example of that for everyone in the class was the hospital readmissions exam, where you are predicting people who get readmitted, and then you assign a cost. So you say, okay, if someone does have to go back to the hospital, that costs $100 per month. And then if someone goes home successfully, they don't cost anything. And so you look at the confusion matrix and you assign a dollar value to each group, if it's true positive, false negative, true positive, and then you choose your cutoff value to maximize the cost. That's a question that comes up frequently, because they sort of have you fit a model, and then they want you to take Microsoft Excel and like do some financial analysis on the end to do just that. One question is about model selection. We have different types of models, decision trees, linear model, generalized linear models, lots of extensions of GLMs with like stepwise selection, and then boosted trees and bagged trees. How do you know, or what are the pros and cons of each method? What's your your to-do list when you're choosing a model?
Is that a question for me?
Yes.
So, there's a few things out there. One thing that I even start with is a conversation with a client on the trade-off between complexity and performance, because they themselves may decide that they only have a limited amount of capacity for complexity. Often, stratified models will outperform a single model, but stratifications can get confusing. So I start with a question of, if I stratify your customer segments, what's the amount of strata that you can deal with? So I'm worried about operations, and that's a main thing that I care about. And I balance that with performance. So for example, if I have a trivial linear regression model, and that comes within 0.2% of my most advanced GBML model, I'm going to have the honest conversation. Is this worth the complexity? You get a little bit more prediction, but do you want it? And some clients will say yes, some clients will say no. When I start with this stratification, I'll ask them operationally, what can you handle? I'll explain to them, what does stratification do for you? Why am I doing it? But then they will come back with a reasonable answer. And the reasonable answer will control the level of complexity. So I'm very, very concerned whenever I do modeling, not just about how well the model does, but operationally, can they use the model afterwards, or is it just simply unmanageable? Stratification, fantastic question. when you take your population and you divide them into subgroups, and then you build models on the subgroups. Clustering would be a good example of it, but it isn't always clustering. In the medical space, often they stratify, they define subgroups based on age or sex or a particular comorbidity stage or a particular insurance stage. So they have these subgroups and they model the subgroups separately. So that's what I mean by stratification. Truth is, some companies can handle a lot of that. They're okay having 20 models running at the same time. Others say, too confusing, we don't want to deal with it. 2, 3 models at most. So operations is my biggest concern. Performance, I kind of combine that in the conversation with them. Because the biggest failure you can have is to have an amazing model that you spent so much time building and no one will ever use it. What you don't want is someone to call you an academic.
Howard, I am going to put
you see that email from Columbia University. Don't be called an academic.
I'm going to
show them that you can deliver models
and ask you the same question that I asked 2 data scientists last time, and see how you answer it. So this is a one of the practice exams, and it's apartment applicants. So for each property, you're predicting the number of people who are going to apply for that property based on the characteristics like the size of the unit, if it has air conditioning, if it has a garage. And so you're given, a data set, you split it up into training and test sets. And what you want to do is to make a model that is as accurate as possible. And then this question is asking you to interpret the variable importance graph. So this was from a random forest, and it's showing the % increase in MSE if the variables randomly permuted, and then you can see all the variables. So using non-technical language, interpret the following importance output that came from a random forest. Make recommendations for a property manager who wants to find the most profitable apartments to invest in.
You want me to take an exam right now? Is that what you're trying, Sam?
Yes, I want you to take a swing at answering this question.
I think what I'll do is I'm not going to write 7 sentences right now.
Okay, just explain it, yeah.
But what I would say is, typically variance importance graphs, they're very helpful. People will sometimes have a threshold associated with it. In this particular case, it seems like it's quite dominated by what is the price per square foot. And so as a result, what I would want to have a better understanding of is what were the other types of models used? Because when you have one variable that is dominant, then I have to wonder, is random forest even the right solution? The reason why is, if you see this here and you see that the vast majority of the variance is explained, well, by the first 3 or 4 variables, it suggests to me that you might be able to have a linear regression model, which includes the main effect terms, interaction terms, and maybe polynomial terms, and you might actually be able to explain as much or more variance than what you've done here with one third to 1/4 as many variables. So that was my quick take. But I'm not using, I'm purposely not using non-technical language because I'm not taking the exam right now.
Yes, that's the key. So what Howard said is absolutely right. If he were taking the exam, he would have gotten a terrible grade on that question. He would have flunked the test. And that sort of illustrates the point that you can be statistically right in everything you say, but not get credit because you're not following the instructions. So it's just really important that you do exactly what they want to say. Like this is a model example would be, our model identifies the key drivers of rental demand. The following graph shows the relative influence that each characteristic of the apartment, et cetera, et cetera, et cetera. I already talked about these yesterday, but it's, basically, keep all the statistics in your head, but then sort of simplify it and just do exactly what the question asks you to do.
So to Sam's point on that, when you're grading and when exams are being graded, most people have a checklist. And they're, if it's, assuming that this is manually graded or if it's automatic, I promise you, it's literally going across checklists. Did you do A? Did you do B? Did you do C? Did you do D? If so, you get this many points.
Yeah, and that was actually a perfect segue. This wasn't staged, I promise. But our next part is going to be doing that. So here you can see a graded example. So this was from one of the people in our group here. One of our audience members asked this question, and they were comparing their answer to my answer, and also like the official graded solution. So this is the question. It was worth 12% of the exam, and it says construct a boosted decision tree. Explain what boosting does and why it might be considered useful for this problem. And so, just like Howard said, the grader would just create a checklist like this. It'd say, okay, each of these bullet points is going to be worth 3 points. The second point is plot the partial dependence. The next part is plot the tree, etc. So we can look at these two answers. I'm going to call this person Joe for the sake of anonymity. And then this was my official answer from our video solution. So this first part was perfect. Joe explains what a GBM is very concisely. And then there's one improvement I would say is just the word choice. So in Microsoft Word, if you just look at the little blue underline, it will tell you when you can use a better word. My question was a little bit long-winded. So I start by sort of rambling about, it's important to consider the business application, et cetera, et cetera. I wouldn't take points off of that because you can't really take points off for being too long, but it would cost me a lot of time. So I wouldn't have as much time in other questions. The next part, I lost 3 points, and I would say Joe would lose 1 point here. So Joe says, I ran a GBM with 1,000 trees, a shrinkage of 0.001. The two variables with the highest relative influence were hour and temp. So I used these in the partial dependence plots right here. I completely misinterpreted this question because I was looking at, so the project statement said, here it is. Plot the partial dependence for each of the two most important factors. So I read factors as like a factor variable, as like a categorical variable. And so I was looking at, these two graphs, year and weekday, when the real question was asking for hour and temperature. Joe did a great job of pointing out this flat region here. He says the partial dependence plot shows the marginal effect of the variable on the target. So the top graph for hours showing when the hour is around 7 to 18, and it drives up predicted value of bikes per hour. When the hour is between 0 and 5, very few people are riding their bikes. That's right here. Similarly, the bottom graph shows that the comfortable warm temperature between 0.6 and 0.8 drive up high bike value uses, but when it's very cold, less than 0.0, hardly anyone rides. And so on my answer, I actually explained a partial dependence plot for a factor variable, which is actually quite difficult to do because this is really, binary. You only have a 0 or a 1. But, just because Joe had a good answer doesn't mean that he couldn't have a better answer. Here's how you could improve. You could just change the tense or the perspective from, so it's a partial dependence plots show the marginal effect of the variable on the target, adjusting for all other variables in the model. The top graph shows that when hour is around 7 or 18. So to make this easier to read, you can use a bold on your variable names. And the expected value of bikes per hour increases. When hours between 0 and 5, very few people ride their bikes. Similarly, the bottom graph shows the warm temperatures between 19.8 degrees Celsius and 29.4 degrees Celsius. So that was just converting the normalized temperature values to the actual temperature values so that it's easier to read. So right now, I would say that Joe has 11 out of 12 points, and my answer only has 9. And then, yeah, in total, the grader would look at all of these bullet points, and they'd say, okay, 3 out of 3, 2 out of 3, 3 out of 3, and then assign the grade for that question. And a grader is just going to be like an assembly line. They're just going to look at the same question over hundreds and hundreds of people so that they can be as consistent as possible. So that's why it's really important to follow exactly what the model solution is saying. Now I'm just going to sort of
Dan,
pause.
I'm
and
just
see-
going to come off mute to say goodbye. Wish everyone the best of luck.
Yeah.
So terrific. Best of luck with the exam.
Thank you, Howard.
Thank you very much. I appreciate it.
Hi. So now we're just going to go to more of the exam focused questions that all of you have asked. So we do have about more than an hour to go. So if you have any questions before then, we might even be able to sneak those in at the very end. The first question is about candidate IDs. Are we allowed to write down our candidate IDs on a sheet of paper and bring that into the exam? Also, I say something about including our candidate IDs in the names of the Word and RMD files, but should we have them anywhere else in a comment in the RMD header or Word doc? Yeah, so in every file you submit, you need to include the candidate ID. There will be a spot in the Word and RMD files. You can get your candidate ID from the SOA website. If you just Google that, there's a link there. You get it in your email when you like register for the Prometric exam. Question about exam time. I was wondering what happens on the exam if your time runs out as you're writing the summary. Also, how much time should I allocate to uploading? So you have 9 minutes at the beginning. You're going to walk into Prometric. You're going to check your ID. They're going to give you headphones, a pen, the printed project statement, and then you're going to sit down and you'll go through the Prometric tutorial. You can also read the project statement at that time. It's a good idea just to skim over it. And then the clock starts and you have 5 hours and 15 minutes to work on the exam. Files can't be uploaded until you get to the upload time, which is 5 minutes at the end. It's a good idea to save your Word file. Just press Control S and save your RMD file as you go. And if you do, for some reason, delete part of your file or you need to go back to get a fresh copy, you can download that. And when you get to the end, you can just skip the survey and just, get out of there. You've already been there for like more than 5 hours. Next question is interpreting logit or probit coefficients. So the short answer, so I was wondering if you can help me better understand how to interpret the model's coefficients when using a binomial or logit or probit link functions. I noticed in the hospital readmissions task 8 solution, you were able to code this up in RStudio. When reviewing the SOA solution, they made a comment that this can also be done in Excel. See below of the SOA's coefficients for the probit link function as well as their interpretation table. Can you give me an example of how this would be done in Excel for both the logit and the probit link functions? Yes. So I did go through this in Excel. And the way it works is for a GLM, you have the mean of the response, which is related to the linear predictor, which is the product of all of the coefficients times the variables, and that's related by a link function. And so for like logit, you have the log odds, and so you need to inverse that function. And for probit, that's an inverse standard normal or Gaussian CDF, and so you just invert that by using the Gaussian CDF. And so in Excel, it would look like this. So you need to have a single observation. So like, let's say you're predicting a specific person, whether or not they'll be readmitted. And so these are the coefficients, and then these are the values. And then the linear predictor is the sum product of these. And then the survival probability is e to the z over 1 plus e to the z. And then for a probit link, you can use this norm.dist function in Excel. Just be careful that you use this true statement at the end, which uses a cumulative distribution as opposed to the PDF. So it uses the CDF as opposed to the PDF. Now, I wasn't actually able to match these values exactly here, like 0.09855. I really couldn't figure that out. I spent like 20 minutes looking at it. I'm not exactly sure. I would just reproduce the SOA's code again, but it's from an old exam from like 2019. And so I need to update my version of R before I can do that. But on your exam, you shouldn't have that difficulty. It is just a simple formula. It's just that e to the x over 1 plus e to the x to go from logit, and then the norm.dist function for the probit. This was just another question about, this is from an old exam. This is from the student success exam, which is like one of the earliest examples, but I wanted to give it to you because it is something that could come up, which is related to feature engineering. So, so let's say you're given like, these different, so in this exam, you were asked to just create different features, and they created these features daily. So what the problem is that you're looking at students, like high school students, and you're predicting whether or not they're going to pass their end of semester grade. And you look at like their age, how often what their hobbies are, how often they go out with friends, if they drink alcohol, and so forth, their mother and father's education, and so forth. And the question is just come up with some new features. And if they do ask you a question like this, there's a lot of different things you can do. Like you can multiply the two variables together. And this is because alcohol consumption may be compounding. So if you have two variables, and if one is higher, then it makes the other one have more of an impact. Or in other words, that's just an interaction effect. Then you can multiply the two together. Same thing with mother's and father's education, right? They just multiply them together. And so there's a lot of other things that you could do. The next, so this is the actual SOA's answer. I noticed that, actually, no. So this is another question, another audience question. I noticed that in June 16, 2020, patient's length of stay, the project statement explicitly said to interpret the original GLM and not the lasso GLM. My question is as follows. If we binarize data and run lasso, we will drop some feature levels. An example from this exam was only a few age buckets were included as significant, and the other binarized variables were dropped. Let's say, 0 to 20, 20 to 40, and so forth. But if we ultimately use this GLM as a final model and go to interpret the coefficients for Poisson with log link, it is appropriate to say the base level for the intercept is any age that is not specifically included in the model. For example, 40 to 50, 50 to 60, 70 to 80. For example, if age bucket is 0 to 20 and there's a multiplicative impact in the intercept of X beta. First of all, this is a really good question because it demonstrates that you understand a lot of things. You understand the GLM, the lasso, binarization, variable interactions, and also binning, which is when you put the variable into bins. So the easiest way to explain this would just be to look at a little example. So let's say you had, age, and this is like just a number. So for each person, this is Bob, this is Sam, this is Sue, this is Mary. You know what their age is. And when you create the indicator variables, you're going to say, a new variable, which is age 10, age 30, age, let's just keep it at 2. So for this person, it's 1 and then 0. And then for this person, it's 0, whoops, and then 1, right? And so, so first of all, you create these binary values, but you know that if you put So let's say you fit like a linear model that was just, you know, y follows age 10, right? So that will only need two coefficients. It will have the intercept beta 0 plus beta 1 x1, and this is x1, so it's beta 1 times age 10. So this will just be 0 or 1. So like if the reference level, if the base factor level for this age 10 value is 0, that would be people who aren't age 10, then you know, this will not make an impact, except when the person is age 10, then there would be the coefficient added. But when you do binning, you're actually doing something even more complicated. So like, let's say you're creating bins like age 10 to 20, age 20 to 30, age 30 to 40. So this is 1, 0s. This is all 0s, 1, 0. This one 30 to 40. We'll have to assume that this is like, you know, not inclusive of 30. Okay, so now you'd have these variables. So you could fit a model like this. Y is age 20, 10 to 20 plus age 20 to 30 plus age 30 to 40. And these variables would be binary predictor variables. So each one of them would have a base level, which would either be 0 or 1. It would most likely be 0 because that's where the, you know, most people are not going to be in that bucket. And so then if you fit a lasso, you might get like a simpler result. So like, let's say this is your model, and then after lasso, you remove this first one. So then you just have this model. So it's just age 20 to 30, age 30 to 40. And so at that point, if a person isn't in age 20 or 30 or in age 30 to 40, then you can infer that they have to be in age, you know, 0 to 10 or 40 plus, right? So that would be the reference level. So yeah, so you know, ideally, you know, your reference level is always going to be the one that has the most observations. But if the project statement tells you to use a specific algorithm or to do things in certain steps like this, then you just have to follow what the project statement's telling you to do. Let me just stop the screen share so I can read the chat. Okay. Thanks. Can you please also explain log and identity? Yeah. So log link function is, you know, let me see. Log link function, identity is the easiest. Identity just says that the mean of your target is your linear predictor. So let's see if I can do this. Screen share. Whiteboard. So for identity, you just say that y is equal to beta 0 plus beta 1 x1. And so like, let's say your family is you know, gamma, and your link is just identity I, then it means that you have, for each person, you have a gamma distribution, and the mean of that gamma right here is just equal to that beta 0 plus beta 1 x1. And then for log, if you had, so if you have a log link, then it means that your mean, the log of the mean is equal to beta 0 plus beta 1 x1. So therefore, you take the exponent of both sides, the mean is the exponent beta 1 x1. So does that make sense? Is that answering your question? So to interpret, your coefficients, let's say you had, x1, x2. Oh no, let me. I think that answers your question. Let me know in the chat if that doesn't, because we've seen a lot of those examples. We've seen a lot of interpretations of log link functions. You can just look at some of the old practice exams. I think so. Oh, can you explain the canonical link? Is the logit function the only canonical link? No. So the canonical link function comes from the GLM theory. I don't remember the formula right now, but there's this screen share. There's this formula that every distribution that you use comes from the exponential family, which means that the PDF can be written using a specific formula. It's like, like a PDF is a probability density function. Like for the, a binomial, the PDF is like n choose k, x to the n 1 minus x to the n minus k. That's the PDF. And when you're working with an exponential distribution, it's like the gamma, the inverse gamma, the Gaussian, the binomial. It means that you can write it using like this function of exponentials. It's like e to the a of x plus b of, x times c or something like that. I'm just making up that formula. And then each of these components, A, B, and C, when they're set to different values, results in different distributions. Like if you set this part to 0, you just get an exponential random variable, and the canonical link function is the mathematical, so it's the most convenient way of choosing these values. So depending on the family. So like it's basically theoretical, but the theory helps the algorithm to converge most often. So it makes your modeling faster to fit. Like if you look at the GLM output, it will tell you the number of iterations that it took to converge. And when you use the canonical link, often it will be faster when you use that. But it's not a requirement. In data science, the best model is the one that works the best. So you use it as info, but don't make all of your decisions based on it. Always look at the training error and the testing error, the AIC and the BIC. Is the logit function the only canonical link? No. So like different families have different canonical links. In R, if you type in GLM or family, it will show you the link functions for each family. Like for gamma, it's the log link. For Gaussian, it's the identity link. For logit, it's the log odds. for the binomial family, it's the logit link and so forth. Let me know if you have other questions. I'm just going to keep moving on here. We do have more. Yeah, I was just going to talk about model selection. No, what was the slide? Okay, well, let's just finish up this question. So my question was, we did three things. First, we put the age variable into bins, and then we binarized each of the bin values. So we added dummy columns or indicator columns. And then you used a lasso, or you could use stepwise selection in order to remove some bins that are not significant. If we ultimately use this GLM as the final model and go to interpret the coefficients for a Poisson with log link, is it appropriate to say the base level is the intercept of any age that is not specifically included in the model? I wouldn't say that. That's kind of a big leap. I would just explain your process step by step. Yeah, so that is, so does anyone else have any other questions right now? Or would you like me to go through, other examples? Like I could go through that, I can go through examples from our latest exams, or I could, just open up a practice exam and start working. We did book this webinar for another hour, and I'm just, so I'll just keep going. Okay, how about I will just go through one of our practice exams. I'm just going to show you how I would conduct a practice test if I were retaking this exam. So I'll go to our formulas, our folder. All right, let's do this bike sharing demand exam. So first of all, I just need the template files. So just make a copy of this. And that's not working because it's making a copy. Okay, we're going to try a different one. You do have another question. Okay, in one of the practice tests, hours were handled as numeric. I decided in my answer to make them factors. Is there a good guideline on when to make something numeric or factor? Yes, there is. If you can compare the two values, like if you can measure the thing, like let's say you're looking at, well, let me say that again. So when should you make a variable numeric and when should you make it a factor? Well, that question is context specific because it's asking you about for a decision tree versus for a GLM. But in general, if the variable is a number, like it's something you're measuring, then it should be a number in like a numeric type. If it's like a category, like let's say it's weekday and they've coded the values, Sundays equal to 1, Mondays equal to 2, obviously that should be a category. And even better, you can rename the variable levels to be 1 is equal to Sunday, 2 is equal to Monday. So when you fit your GLM, it's easier to read. If you do like bin the variable, then you can make it a factor. Like in the age example from earlier, you're going to have different bins for age 1, age 10 to 20, and so forth. The reason that we do that is because it can reduce the likelihood of overfitting and like in insurance pricing, for instance, you typically would just include bins for ranges of the variable that have a lot of observations. Like if you're modeling patients and everyone is, between, 18 to 65, and you only have a few people who are between 18 to 30, you could just put all of them into one bin. And so the reason why they do that is because it allows you to interpret the result using relativities, or when you take a log link for a GLM, you can just look at the exponent of the coefficients and then break that down into just a bunch of numbers that are multiplied together. So that just makes a very simple list of rules. So you can say, oh, you're a minor, so that's plus $100 per member per month in your premiums. Oh, you're over 65, that means you have to pay this amount more, each month. So to summarize, there's no single guideline. It depends on the question, what they're asking. In your opinion, do you think the new SOA changes related to R code will really cut back on the amount of code they provide? What areas do you think we should definitely memorize related to R code? I would say just look over the modules. Look over the SOA's modules. See if I can just open that right now. I don't remember. So just look over the modules and look at the sort of the snippets that they provide to you, which are always the same for the practice exams. Like you'll notice that, when you're doing like data visualization, they're going to give you like all the ggplot things, to create like the big like facet of like, they show you like all the histograms and all of the line plots and things. Like when they have a for loop, you don't have to worry about that. They're not going to make you write anything in a for loop. They're also not going to expect you to know dplyr. So anywhere you see these, the pipe operators, you don't need to learn that. But like when you're doing like data manipulation, like adding variables, removing variables, filtering out observations, you should be able to do all of that from scratch. And from scratch, I mean by using their template code. So a good exercise to do is our data prep exercise. You go through that and try to just use their code snippets. So I forget where this is. It's in like week 4. Data exploration right here. So you don't have to use the code that I give here. You can just use this as a starting point and copy and paste in the code from like another practice exam when you're like creating these graphs or making changes. So this part is the exercise. This is just the lesson. This is the actual sort of exercise, and then you can compare the result. And when you compare the result, don't try to match everything verbatim, because there are other ways that you could explain things. You could use a line graph, you could use a scatter plot, or you could use in some cases, you could use a different type of graph, or you could just look at summary statistics or use an Excel table. Sometimes you don't even need to use a graph. Should we automatically transform all character variables to factors? Yes, that's my personal opinion. But don't just break the code. If you see that they do something in the template, just kind of leave it, because they'll probably fix it later on. So if you just make a change at the beginning, you might have to go through and make that same change like a million different times. So just, don't make a change unless they sort of tell you to. And should we re-level at the beginning of the exam if we see that there is a GLM question later? Or even if they don't explicitly tell us to do this? I would say no. If they don't tell you to do it, don't do it. Because you could spend time, re-leveling, and then they tell you to drop that variable altogether, and you just wasted your time. But it's good that you can write that. So even if you don't do something, you can say in your report, oh, by the way, I know that I should have re-leveled these variables, but the project statement didn't tell me to. Because you can just write to the exam grading team. Unless they tell you to write to the audience, you're just writing to the grader. You're just writing an email to the actuary who's grading your exam. In one of the practice tests, hours are handled as numeric. I decided on my answers to make them factors. Okay. Is it a good guideline on when to make something a numeric or factor? We already answered that question. In your opinion, do you think the new SOA changes related to our code will really cut back on the amount? We already answered that question too. If we don't know the answer to a question with the exam being graded relative to other test takers, is it better to try a BS an answer and leave it blank? Or how do you think we should approach that? Definitely don't leave anything blank. At the same time, you're not graded based on the number of words that you write. You're graded based on how well you answer their questions. So you can have a shorter answer that answers that gives them everything that they want. So I would say just do your best and explain your process. Like, let's just imagine that I took the exam and I completely forgot what the difference was between bagging and boosting. And the question said, explain the difference between bagging and boosting. I would just try to write everything that I know. Like, I know that random forests use bagging, and I know that GBMs use boosting. And I could say, oh, well, a random forest has fewer hyperparameters. It only has entry and mtry parameters, whereas a GBM has more parameters like the learning rate, the number of trees, the subsample percentage, et cetera, et cetera. And so you could say, oh, one difference between bagging and boosting models is that in random forests, AKA bagged models, there are fewer parameters. And that's not wrong. It's just not complete, right? So I would at least get like 1 point on that. Well, and also just kind of leave it empty and then keep going through the exam. And you might refresh your mind when you get to the end. They might even give you a free cookie at the end. They say, oh, this is the difference between bagging and boosting, in the end of the exam, and you can just use that earlier. Will we ever have to calculate or interpreting the entropy for a decision tree? And if so, how do we go about doing that? Great question. Yeah, we do. In the SOA modules, they do have this really complicated example where they make you calculate it. I remember doing that. I don't expect that it would be that difficult on the real exam. If they did ask you, I think it would be more of, fit a decision tree that uses Gini, and then fit a decision tree that uses entropy, and then, explain what some of the differences are. The answer is you basically need to fit both models and see which ones performs the best. And what you don't use as a splitting criteria is the accuracy, because that's it's not sensitive enough to decide on which splits are good and which splits are bad. So if you look at our trees lesson video, I do go through a simple example like this. So to sort of summarize, I won't even summarize this because I don't want to take up time. You can just watch this video and see how to calculate the Gini and the entropy for a tree. what are your thoughts on making edits, if asked, to the data in Excel if I'm really struggling with making the changes in R? I remember that, Tom. I do remember you're asking me that question. Do you think the SOA would greatly penalize this? My thought is at least it would allow me to do the modeling and perhaps still pass. I don't think so, simply because it's part of what they're testing. They expect you to learn R, and so that's what they want you to do. If you did use Excel, you wouldn't have a way of it being graded. You'd have to go into Excel, make the changes, and then export as a CSV file, and then import the CSV file into R. But CSV files don't have any way of showing like the steps involved. So the grader would just look at your data and just think that you just didn't do anything. And they also wouldn't be able to reproduce it. When they do grade your exam, they're going to run your RMD file from beginning to end, and they're going to expect that the outputs will match what you pasted into your report. So you can't cheat by just making up numbers on your report, or they would catch that. So the good news is that we do have a lot of practice for the data manipulation. So if you just look on like that exercise I showed earlier, that will help you. Yeah, and if you do feel like there's absolutely no way that I can pass if I'm taking the exam this time, that's okay, because they're going to give you feedback. They tell you which areas you did well on. They tell you, okay, you did well on, you got like 4 out of 5 points on data prep. You got 5 out of 5 points on modeling, 5 out of 5 on selection. And so that when you retake the exam, you know what you need to focus on. So yeah, I would say just go for it, do the best that you can. And it'll just help you to become more familiar with the material. And you've also already paid for it, right? So it's $1,200. It doesn't make sense to just throw that away. If you had to guess, and I know this is really a stretch, is dependent on a lot of factors, how many points do you think it takes to score a 6 on the upcoming exam? I think if you're asking that question, you should just be focusing on studying, because that's a moving target. If everyone on the exam scored a 90, then the pass mark would be a 95, right? The points are arbitrary. So they want the pass rate to stay consistent. They're not grading it based on the number of points. I'm obviously going to try my best. Yes, try your best. Absolutely. Give it the best try that you can. As Yoda would say, do or do not. There is no try. So don't even say that you're going to try. Say that you're going to pass, right? Have that positive affirmation and then go do it. And if you need to, and you are going to pass, right? You're not going to, maybe you won't pass this time, but you'll pass next time. Thank you. Write something like time. Whether 24 hours is not, wait, I'm sorry. This is a kind of, thank you. Right. For something like time, where the 24th hour is not 24 times the first hour. Oh, I think are you talking about factor variables versus numeric variables? In that case, yes. Like, let's say your input is time, and it's like bins, like 1 a.m. to 3 a.m., 1, 4 a.m. to 6 a.m., 2. It would be better if you kept that as a factor. I agree. How do you expect questions to be set up with the summary being within the question? Will there be a way for bullets telling you what to do, and anything the last bullet would say something like summarize the first 3 bullets in a non-technical way? That's a good question. And yes, that's a very good example. They might ask you to do something and then have you summarize it. And I think it was the one of the 2020 exams. They say summarize the data for your actuarial manager in like task 3. So in task 1 and 2, you went through and you create some histograms and cleaned the data, removed some records, maybe applied a log transform, and then summarize it using non-technical language. So you'd say like, we wanted to be completely sure that our data was free of any irregularities or errors. We looked at the data, we looked at both visual summaries and statistics in order to ensure that we were looking at every dimension possible. And then like, here's a very simple graph, that shows the distribution of the target variable. And you might show like a simple histogram, make sure that you add a lot of labels, make it very easy to read. And then, just now write as if you were writing, to a sales manager. And bullet points are great, by the way. Yeah, bullet points, that's faster to read, and it helps the grader. Like Howard was saying, he grades a lot of academic papers and a lot of academic tests, and he likes to see organization. So you can use like subheadings where you like make one heading bold, and then put a little paragraph, and then another subheading, and then like bullet points. Yes, that's great. If a question says to explain loadings on PCA or create a GLM and evaluate it, should I explain what a PCA or GLM is, or just answer what's asked? I honestly struggle with this too, because sometimes I do explain things when I don't really need to. I think that's because I'm sort of just in a teaching mindset. So I just sort of look at everything and say, oh, I need to explain this. I need to explain this because I'm creating tutorial videos. But you are not. You're just answering what the question says. It's always good if you can show that you know something, because even if you're wrong, you can still get partial credit for it. Like if you ask me, okay, fit a PCA to this data, and then choose and then tell me what the best principal component is, and I'll say A. A is the answer, and then I grade that and say no, it's B. 0 points. Whereas if you say, oh, well, principal component analysis is a dimensionality reduction technique where you take an original set of variables and transform it into a new dimension, thus removing variables, or thus combining variables that are highly correlated into a new principal component where the loadings or weights of each principal component give you a recipe so that you can take the initial variables and then translate them into the new coordinate space. Like if you say that and then say, oh, by the way, the answer is B. Oh, that was wrong, but you still got partial credit for the first explanation. So it's sort of a way of just padding your answers. Next question. I have trouble identifying interactions for box plots. Can you give me more guidance? Something the box plot looks similar, but the solution says there is an interaction. It is hard to tell. Yeah, it is. Let's just try drawing a picture. You don't need to look at a box plot, by the way. Box plots are just what the SOA happened to use in like the June exams. And so that's what we've sort of copied. You can also look at like facets. So here's the cheat sheets. So like here, so, if you have numeric, so what type of box plot are you talking? So let me rephrase that. So when you're looking at a factor and a factor interaction, then a box plot is useful, but you could also look at just a lot of histograms. Like, let's say, how do I clear this? There it is. Like you're looking at two variables, okay? Day or night, and then hot or cold. Okay, so you could just look at the all the combinations. So you day, cold, day, night. And no, that's not right. That doesn't even make sense. Day, hot. Night, night, hot, cold, hot. And then let's say you're just looking at the histograms, and this will be no interaction, and this will be yes. So if there was no interaction, then only one variable would make a difference. So it'd just be day. So it'd just be so when it's daylight, you'd have this distribution. These would both be the same. And then when it's night, you might have like this distribution. And if there was an interaction, then you'd have different distributions for each one. Like this will look like this will look like that, this will look like that, this will look like that, right? So it's just a way of looking at the dimensions. And does that answer? I think that answers your question. When you look at the box plot, it's just another way of showing you the distribution. So in R, the way you can do that is using facet wrap. So you do like geom histogram and then facet wrap. Var is equal to day and night. Because I think in facet you can use multiple variables. You can do like facet wrap day, comma, night. I know I should never take a log transform as a target variable, but I recall reading an SOA solution for the first couple of tasks on data exploration. They compared the log of the target to the predictive variables. Do you recommend doing this? Yeah, I know. I do remember that. I think it's in the traffic safety exam from the PA June 2019. Where the target is like crash score, which is a continuous positive value. And when they're looking at the histogram, they say this is right skewed. But when we apply the log transform, you can see that the graph straightens out. And they just do that to the histogram. Then when you fit the GLM, they use a log link function on the untransformed variable. But what you don't want to do is transform something, using an inferior method. That using a log transform is what you used to do before you knew what a GLM was. Before you knew that you had a log link function where you could relate your linear predictor to your target using that additional function. You used to rely on the primitive version of just transforming the target. And also there's an example in one of the late exams where you transform the output of a decision tree. I think that was in the either pedestrian activity or bike sharing, where they ask you to look at the square root transform, the square transform, the log transform, and the way that you choose that is you just look at the histograms and you choose the one that makes the distribution more symmetric. That's because in a decision tree, when you get to the end leaf node, you end up taking an average of all the values in a bucket. So if your variable is very skewed, taking a mean is sensitive to the skewness. So the mean will be skewed in the same way that the data is. So when you apply the transform to the data and then fit the decision tree and then take the mean at each of the leaf nodes, the predictions are better. Can you go over how to interpret PCA loadings or just how to read a biplot? Yes, I can do that. So we do have this example from the cheat sheet. So so the way to read this is that A and B. So here you see PC1 and PC2. So if you were so the way that this was created was you had data like this. You had A, B, C, D. Oops. So these are just numbers. And then you wanted to go from, so then you would run PCA and you get 4 PCs. PC1, PC2, PC3, PC4. And these would also just be numbers, except they would be their principal components, so that so there'll be linear combinations of A, B, C, and D. And if you want to reduce the dimension, you can just choose like the first 2, or you could choose the first 3, right? So so that's what these are. So like, let's say that these vectors E and A were almost what's the word for it? Not adjacent, or they're completely uncorrelated, or orthogonal. Now orthogonal is 90 degrees. I'm not sure what the word is for that. So it would be like negative. So like E is almost equal to like negative A. Then that would be like, oh, there's an E here. Then there's like an E. This would be like approximately negative A. Or like think of it in terms of like practical cases. If you're like talking about A being temperature and E being snowfall, you know that when the temperature is high, the snowfall is going to be low, and vice versa. So they have a negative correlation, right? So it would be something like that. And then B and C, these two, so green and red would be orthogonal. So that means they would be uncorrelated. So let's say your snowfall and the amount of coffee that I drank that morning, right? There's just no relationship between them. And then D and B would be like, the red and the yellow. These would be like positively correlated. Like, let's say it's you're looking at claims. It's the person's age and their annual cost. As they get older, they are more expensive. Does that sort of answer your questions? I think we do have some examples of PC, of principal component analysis in our exams. I want to say it's like the traffic safety exam. I think it's principal component analysis. If you look through our older exams and then look at the tags underneath the video solution, you can see, or you can just type in the search principal component analysis into our website, and it should bring up the practice exams that have that. Do you think quasi-Poisson or quasi-binomial distributions will ever be needed or appear? Great question. That is on the syllabus, although they have never appeared on the exam. So the way to test that is to look at the mean and the variance. If the mean, so for a Poisson distribution, remember you have one parameter, lambda, and lambda is equal to the mean and the variance. So if you look at your target's mean and your target's variance and they're radically different, then that means you need to use an over-dispersed Poisson, or rather the quasi-Poisson. And then for the binomial, you know that like the mean is just P and the variance is P times 1 minus P, right? So you can just look at the mean and then take the mean times 1 minus the mean. And I think you should get to the variance. And if that doesn't work, then it means you need to use the quasi-binomial. And everything should be tested. You should have a training set and a test set. You should fit both models and then look at the performance, the AIC, the root mean squared error, the log likelihood, you know, whatever it is that you're using. If yes, can you give a quick description of these and when they would be used? Yes, I can. I think there was actually an example. I'm trying to hunt it down, but I did like have a hypothetical answer where I was thinking, how could I do that? Let me see if I can find it. If I can't find it right now in the next like 5 seconds, I'll email it. I'll email it and put it in the forms. But it was for the pedestrian activity, right? Because you're counting the number of pedestrians in an hour. So you can try just fitting the quasi-Poisson to that data, you know, and just add another model and then look at the performance. Is the AIC better or worse? It's a good question. Should we rebalance classes if not asked to do so? So I summarize, you know, rebalancing classes is because, you know, your classes are imbalanced, meaning that there's more in one class than another. Let's say you are modeling loan defaults, you know, and most of your loans don't have most of your loans are fine. They're not going to default. And only like 10% of them are at a risk to default. If you just trained your model on that data, then the model will be good at identifying loans that are safe, but it won't have many examples of loans that are false. And so if you end up just training your model, it will just predict that all loans are safe. And so you need to use rebalancing. So the way that you do that is you can oversample the number of defaulting loans, or you can undersample the number of the safe loans. There's also another technique. It's not on this exam. It's called SMOTE, synthetically majority oversampling technique. I think that this exam just uses over and undersampling, and you use the carrot library to do that. That's never appeared on an exam before. But what you do check is that the percentage of the mean target is the same in your training set and in your test set. So yeah, if they don't ask you to do it, I don't think it's necessary, but definitely comment on that. And when you get to fit your model, say that, or in the executive summary, there used to be a section where you talk about future considerations or next steps. If you have a question like that, where they can ask you, what would you do differently if you could repeat this analysis? And you are working on an imbalanced class, you could say we could rebalance the classes. Weights and offsets are the worst. I know you went over this in the apartments practice exam. Can you run through when to use an offset versus a weight? Yes, I wouldn't say that they're the worst. I would say that they can be confusing. But really, once you look at this, you'll see that it's actually very straightforward. So a weight is your measure of exposure. And an offset is just a constant term. How do I think about this? So like, you all know how to take like a weighted average. Like you have, your vector W, which is your weights, and your vector X. So like if you want to take the expected value of X, it's, the sum of weights times X over the sum of the weights. And for GLM, I'm just going to use a GLM example, but it actually applies to other types of models too. So the expected value, is the expected value of Y, which is your model, is, beta 0 plus beta 1, X1, which in model matrix term is just X times beta. Well, if you add weights, then you have like an X times W times beta. So it means that different observations get weighted differently. So let's say you're predicting insurance claims and you have different lengths of policy period in months. So your exposure is the number of months of the policy. You know that policies that are longer are going to have more claims. So that's your weight. So then what's an offset? So an offset is a way of it's a way of adding a linear term to the predicted, let me say that. An offset is just a constant that you add to your, it's a constant variable that you add to your linear predictor. So I'm trying to think of an example. This is a real example. So let's say that you're an actuary and you're fitting a model for life insurance. Let's say it's mortality. Let's just keep it at claims cost. And so you already have your predicted value. Like, let's say this is Y hat 1. So this was like, some actuaries in 1990 created a model for predicting claim costs. And then you want to compare that to, your new model. Once you've added in new data, you're using a lasso regression. You've done all this fancy feature engineering and so forth. So like let's say like Y1 was just really simple. It was just like, X1 plus X2. And then Y2 was, X1 x2, x3, x37. And you wanted to know, does this model improve upon this model? So you could, so rather than having to refit the whole model, you could just use this as a predictor into this model. So you'd say y is equal to beta 0 plus beta plus this is y2, y1 plus beta 1 x whatever 1 beta 2 x2 plus, right? So if you, so this is just the constant term, or you can think about it as having a coefficient of 1. So if you were to look at this in a table, you'd see beta 0. Well, let's just say that this is person. Here's Bob. Here's Sarah. Here's Sam, right? The intercept is the same for all people. 1.5, 1.5, just some number. And then this is going to be different because this was the model that we fit in 1999. So this might be 37, 100, 99, and so forth. And then you have these. So you have the coefficient times that person's variable. So you have beta 1 times x1. So let's say Bob, let's say, so this might be different for each person. And all of these would be different for each person. But this coefficient is chosen based on the maximum likelihood. So these are actually, estimated. That's why they have this hat on them. Whereas this isn't estimated. It's treated as a constant. So that's the offset. So the reason why you'd use an offset in this case is so that you don't change everything that was done in 1990. You could just use those same, that same model, and then, fit the new model on top of it. So from a regulatory perspective, that can make it easier. You wouldn't have to, get all of this new information past regulators, or you already know that it's working. It's already worked for 20 years. Let's keep using that, and then we'll just try to improve upon it. So it is 2:53, so we do have 7 minutes left. If anyone has any other last minute questions, you just send them to me in an email. I am going to be online for the next week. If you have exams that you want graded, maybe you've answered a question in a new way, you've used a different type of model than what you've seen in our solutions, or you just want feedback. You want to know, am I doing this right? How could I improve? I gave myself a grade of 90 on this exam. Do you agree with that? Do you think that you would actually get a 90? I'll give you some feedback. If enough people send in their exams to be graded, I can even help to give you some comparisons. I'll keep everything anonymous, of course, but I'll be able to say, a lot of people seem to be having difficulty with hierarchical clustering. Here's some other resources that you can use. If you do like, and the other thing I would just say is just focus on, consistency. You don't need to be like you're not going to be able to learn everything. There's just not enough time, and it's better to focus on your routine of sitting down for 5 hours, waking up at the right time and just churning out words on the page, being able to type quickly, Those are the intangibles. Like in baseball, you'd say like a player is like an intangible asset because they're going to always play in the game. They're not going to get injured. They're going to have a good eye. They'll get on base a lot of times. Even if he's on a hot streak, even if he's hitting home runs, he'll still be an intangible asset. So just try to focus on your intangible assets, like writing cleanly, not making grammatical mistakes. I said studying at the right time, using right formatting, making things in nice subheadings, using bold when you need to, and also your process. As you do practice exams, you'll just be able to know, oh, I'm spending too much time on this question. This is only a 5-point question. I've already spent 30 minutes. I really need to keep going. That's going to help you out a lot, regardless of what you see on the test. One other thing to note is that I think when the results come out, you will have a better idea of how you did because there's only one practice exam. There's only one version of this exam. In the past, there were two versions. And so when you looked online and on Reddit or Actuarial Outpost, you couldn't compare yourself to everyone, but now everyone's taking the same test. So don't let that sort of discourage you because, oftentimes, what people post online is misleading. Honestly, in my experience, it's the people who are posting online, they're sort of insecure, that want to get validation, or it's the people who like completely aced it, that studied 600 hours and they want to brag. So don't base your thought of how well you did, just based on that. So that is it for this webinar. Yeah, thank you everyone for joining. Feel free to email me your follow-up questions. Best of luck on this exam. I know you're going to crush it because you're already on this webinar. You've already taken this course. You've already sat through all these lectures. You've already grinded out all of these practice exams. And yeah, you have everything that you need. You just got to go there and you just got to execute.